So we've talked about sine and cosine, and we know how they occur in a right triangle. We've learned that sine is the opposite side measurement over the hypotenuse. Cosine is the adjacent side measurement over the hypotenuse. And just let's bring it in, even though we haven't talked about it yet. The tangent would be then the opposite side over the adjacent side. So here we have two triangles, and they are both 45, 45, 90 triangles. I can take this and I can show you that if I measure this angle right here, let's get it lined up perfectly, but you can see that it is 45 degrees, and then I can show you that over here this one is also 45 degrees, because if I line that up you'll see that it's 135. There we go. Close enough. Also, if I take my ruler, you will see that since it's a 45, 45, 90 triangle, that the sides have to be the same. So this is 9.5, so that means if I measure this other side, that should also be 9.5, thus creating 45, 45, 90. So if this is 9.5, this is 9.5, and if we remember our ratio, this is a 1 to 1 to radical 2. That means all I have to do to find the measurement of this hypotenuse right here is take this 9.5 and multiply it by radical 2. Likewise, this 45, 45, 90 triangle, if I measure their sides right here, let's see, this is about 5. So that means if I measure this one, it is also 5. And again, since it's a 45, 45, 90, this is 5, this is 5, we know that this is 5 radical 2. So hopefully what we're trying to show you is that no matter what, if I take, let's say, no matter what I do, if I wanted to take the sine of 45 degrees, it is the opposite over the hypotenuse. And when that reduces, I get 1 radical 2, which is radical 2 over 2. Same thing would happen over here. The sine of this 45 is the opposite, 9.5 over 9.5 radical 2. They cancel out, we get 1 over radical 2, which rationalizes to radical 2 over 2. So we've been through this. This is just a review. So where are we going to use this with our lovely unit circles? Well, now we're going to start throwing more random numbers at you, but we'll start off with some nice ones first. So, for example, they're going to challenge you to see if you can think through this. They're going to tell you the sine of some angle is 3 over 5. Now, as soon as you see that, they want you to draw into your head a right triangle, because that's the only way we can deal with sine of an angle being a measurement. They also tell you that it lies in quadrant 2. So, okay, so that means there's some point over here in quadrant 2, I don't know where, but when I do draw this right triangle, remember, here's the guy with his sextant looking up at a star, and then we would drop that down to the x-axis, thus creating a right triangle. Then they gave us some information about this. They said, well, we know the sine of this angle. Well, I won't call it that. I'll call it beta, because that's what they told me to call it. Sorry, it doesn't look that great. They told me the sine was an opposite measure of 3 and a hypotenuse of 5. So now this unit circle, don't get confused. Remember, the radius can be any measure, just we call it a unit of 1. In this case, we're saying it's 5. They want us to find the cosine of theta. Well, the cosine, not theta, sorry, beta, the cosine of beta would be the adjacent over the hypotenuse. So hopefully you know this is a 3, 4, 5 triangle. However, now this is where people get a little confused. This is actually a negative 4 over 5. And people start saying, well, wait a second, it's a measurement. How can a measurement be negative? Well, because we're actually looking for the angle. And it's in quadrant 2, we went in a negative direction. So the cosine of this angle is negative 4 over 5. Okay, so moving on to example 2, let's see what they want us to wrangle with then. All right, cosine of some angle is 1/3 and lies in the 4th quadrant. So I always draw myself a picture. I know you people don't like to draw any extra, but it helps. And since it's in the 4th quadrant, let's get my dot over here. And let's travel along our unit circle till I get to the 4th quadrant. Same thing's going to happen. I'm going to create a right triangle. So in this case, the man is looking down to the point, and then we drop a line to the x-axis only. And we create a right triangle. This is the angle in here they want me to find the sine of. All right, so cosine is 1 over 3. So that means the adjacent measure is 1 and the hypotenuse is 3. So in this unit circle, the radius is 3. So 1 unit is worth 3. And they obviously want me to find the opposite side because I need that to do sine. So I know the sine of this angle is something over 3. Well, I've just got to come back here and do Pythagorean's theorem because it's a right triangle, and that's how we find missing sides of a right triangle. So a squared plus b squared equals c squared. 1 plus x squared equals 9, so x squared equals 8. So x equals the square root of 8, and aha, that's why they said simplest radical form. So that means I'm going to have to reduce this radical 8 to 2 radical 2. Now, when I take the square root, I do have plus or minus, remember. So which one is this, plus or minus? Well, there's 2 ways you can think about it, but I just like to think about a point. So if I were actually drawing this point, I went over in a positive direction on my x-axis, and then I went down a negative direction on my y-axis. So thus, I'm going to pick the negative. Okay, now don't stop right there because that wasn't the point of this problem. Just because we did some work here and we taxed our little brain doesn't mean we're done. We have to enter that into the problem. So the sine of this angle is the opposite side over the hypotenuse. All right, number 3 here. A terminal side of an angle, passes through the point negative 3, 7. What's the sine of this angle? Wow, they didn't give me any information like they did over here where they told me exactly what the sine or the cosine of the angle was. So I have to create everything for myself now. All right, so a terminal side of an angle. Okay, so that means I've got an angle, shockingly, rotating around this circle. And let's make that pink so it stands out. And it stops at negative 3.7. Well, negative 3.7 would be negative 3.7. So if I take this angle and I rotate it, that's where it's stopping. Now, as usual, I'm going to create a triangle. So I'm going to drop my line down to the horizontal, to the x-axis, and this is the angle they want me to find the sine of. Well, I need some measurements. So the sine of this angle is the opposite side over the hypotenuse. So that's what I'm charged with finding. What is the opposite side? What is the hypotenuse? Well, this point right here of negative 3.7 means I went over negative 3 and I went up 7 to get to this point. But that doesn't give me the hypotenuse. Oh, no problem. Pythagorean's theorem does. So hopefully, Pythagorean's theorem is something that you just comes flowing out of your brain effortlessly. So that would be 9 plus 49 is c squared. So that's 58 equals c squared. Let's see, this 58. So 58, I don't think, nope, 4 doesn't go in there, so there is no perfect squares that go in there. So c is the square root of 58. Now in this case, c is the hypotenuse. We never have to decide whether it's positive or negative. It's always positive. So the sine of theta is the opposite side, which is 7, over the hypotenuse, which is radical 58. And if I rationalize that, 7 radical 58 over 58. So I told you, we're going to start getting some strange numbers now, but that's okay. The terminal ray of an angle is in standard position, passes through the point negative 0.28 and negative 0.96, which lies on the unit circle. Now, why is that in red? Well, okay, no crap, it lies on the unit circle. So the same thing, we've got our ray here. It got rotated to negative 28, there I am in the negative direction, and then I go down negative 96, so I'm right there. I say which of the following represents the sine of this angle. Obviously I didn't finish typing this question out, but no worries, we can figure that out. I'm going to continue to draw my triangle. So I always attach to the x-axis, and there's theta. Well, they told me that I went over negative 0.28, I went down negative 0.96, and I need to figure out what the hypotenuse is. Or do I? But we're going to take this the long way just to show you that it works no matter what you do. Well, Pythagorean's theorem says a squared plus b squared equals c squared. So negative 0.28 squared plus 0.96 negative squared should get me c squared. Let's take out the good old calculator. So negative 0.28 squared plus negative 0.96 squared. Oops. Put those in parentheses. Negative 0.28 squared plus negative 0.96 squared equals 1. Okay. So c squared is 1, so c has to be 1. So this is 1. So the sine of this angle is the opposite measurement over 1. So the sine is negative 0.96. Hey, well, that makes sense because anytime I do a point on the unit circle, it goes cosine sine. So why couldn't I up here just say the sine was 7? Why do I get this answer and not just 7? We'll talk about that tomorrow. It's got something to do with that right there. Bye.